Hello, everyone. This is Module 5. We have been spending a whole month on deep learning already. And next week, this upcoming week, we're going to talk about the last sort of basic model that we're going to look at before we get into the advanced topics and also your final project. So the next topic is text and sequences. Sometimes it's called natural language processing. The words come in a sequence of text, and so you're going to be analyzing things in sequences, and also those models can be applied to any kind of other activities or events that happen in sequences. I am going to summarize some of the issues that I have been hearing from students over Module 4. I'm going to clarify a few questions I have heard, and I think these discussions are probably useful for everybody. So number one is data labeling for computer vision. I want to remind everyone that what we're doing in Module 4, computer vision, is really a type of... Hello, everyone. This is the beginning of Module 5. We are going to start talking about text and sequences, and that's natural language processing, sometimes it's called. So this is the last module where we talk about like a basic type of deep learning before we get into the advanced topics and also your final project. I'm going to summarize issues I've seen from Module 4. I got some really good questions, and I'm going to answer all of them here. So I've already talked to students individually, but I want to kind of recap the major questions that I got. So one is how computer vision actually works. And computer vision is a type of supervised learning, which means that you need to have the correct answers, the correct Y values, and somebody has to label the data for the computer to learn. Someone has to actually teach the computer by labeling images as dogs and cats in the dogs and cats data set. Label data set actually is critical for deep learning for any kind of computer vision. And our homework is actually relatively easy because the labeling work has been done for you. All the images are labeled properly as dogs versus cats in these exercises. However, in the real world, most of the data are unlabeled, and labeling data is actually a very labor-intensive process, and it can get very expensive. A lot of these big companies, Google, Facebook, they outsource the data labeling work to companies that specialize in that. So you can get into the industry of data labeling itself. There are lots and lots of these sort of specialty industries within the world of AI. And think about who labels image data for self-driving cars. For example, the cars that are driving on its own, it's actually generating thousands and thousands of images for every minute of driving. And a lot of it is, first of all, the cameras on these self-driving cars have to capture the images. And then these images have to be labeled as trees, pedestrians, crosswalks, and so on and so forth. Red light, green light, all these things have to be labeled properly before the self-driving car can learn to distinguish them. So that's a lot of pictures to label. And who is going to label all that? Who's going to pay for it? And the answer is actually you. So you have been labeling image data for the self-driving car companies all these years without knowing that. Every time when you try to create a new account or sign up for something online, a lot of times they will ask you to pass this little quiz, right? Select all the images with traffic lights, for example. And when you're doing that, you're actually labeling these self-driving car images for these companies. What they do is they ask you to select the traffic lights, and they'll do this with a bunch of people. So you and maybe somebody else, and they'll cross-reference your answers to quickly figure out which picture actually has traffic lights, and they will do this on a massive scale, right? And that's how we get people to label these photos very quickly for free for these. Actually, it's not free, but the company that does CAPTCHA, this is called CAPTCHA, and it was invented by Dr. Von Hahn at Carnegie Mellon University. He was a grad student in the computer science department at the time. And it's really free for you and for CAPTCHA, but and for the company that's using CAPTCHA, right? So a lot of the websites can just have this plug-in, but they would turn around and sell the labeled data sets to self-driving car companies. And that's how this company makes money. Another question I got is, why are we dividing a lot of the values by 255? What's the point of this magic number 255 that we see a lot in this chapter? And the answer is about RGB. So RGB is not RBG, okay? RGB stands for red, green, and blue. And this is, I'm just copying the Wikipedia entry for RGB here so that you can learn a little bit about sort of basic color coding 101 in computer science. So every little thing that we see, every little image on the internet that we see, every pixel is labeled usually using the RGB color model. So it's a blend of red, green, and blue. These are three primary colors that can be blended together or added together to create the lots and lots of different shades of colors that we see in the world. So if you see on the right hand side, you have red, green, and blue, and these three combinations with different sort of recipes, you can produce like many, many, many different shades of color. So the RGB color code is represented using this 8-bit color scheme, and it's a binary code, zeros versus ones, but 8 bits, which is a byte, to represent the color of a pixel. So the maximum number of colors that can be displayed at any given one time is 256, or 2 to the 8th power. So that's where the magic number 255 comes from. It's this 256 colors. And because Python index starts with 0, so it's 0 to 255. So again, these are Wikipedia pages. Feel free to read them and sort of educate yourself a little bit about how color is represented on computers. And you will see lots of different sort of color coding schemes, and they're used a lot for every single website, every little thing that you see in the Word document, PowerPoint, all the colors that you pick for your fonts, for your shapes in your objects in PowerPoint. They're all represented using this 8-bit color scheme. Online, you can find a lot of color code generator, right? RGB generator, so you can convert the numbers. You can plug in any number and see what kind of actual number it is. So basically, it is a translation between any kind of color shade to a numeric value that the computer understands. So every single image that you feed into the convolutional neural network is translated into a bunch of numbers. You think that computers have vision. They don't actually understand any images. They are colorblind. They can't actually see. The only thing they can understand is zeros and ones. So all the images, every pixel is actually converted into an RGB combination. It's just represented as a color shade. Okay, so whenever you're using convolutional neural network for image processing, you're processing massive amounts of data. Every picture is translated into lots and lots of bits and bytes. And that's just one image. And then you have thousands of images that you're processing. And if you're processing videos, that's even worse. So what one of the many things that the neural network has to do is to figure out how to deal with this massive amount of data. And one thing it does is to actually reduce data size. And a lot of this is reduction in resolution is actually done by a lot of guesswork. So one of them is called max pooling. So what it does is that, say that you have a picture with a 3x3 grid or 9 pixels. What you can do is you can take any four. So you can take a grid. So it's a subset of this data. And what we do is we look at these 4 cells and we say, which one is the biggest number? I'll only keep the biggest number. So this is 50. And then I'll go to the next grid and then I'll pick the biggest number. So max means the biggest number. So I'll pull 60 out and then I will shift down a row to take the next grid of 4 cells. And then I'll pick the max number 80. And then I'll take the last 4 and then take the largest number in that grid. And so we go from 9 pixels to 4 pixels. So we have cut the number of pixels or the data size by more than half, right? Going from 9 pixels to 4 pixels. And this is what max pooling is saying basically we are unable to just handle the original image size. What we're going to do is going to reduce it. How do we reduce it? We just move, take a subset and take the largest value and call it max pooling. Okay. So max pooling is one of the methods. Another method is called average pooling. So hopefully once you understand what max pooling means, you will immediately know what average pooling is, right? So average pooling is just taking this 4 and then take the average, which is 30 plus 90. So that's 120 divided by 4 is 30. And then we move to the next set, which is 50 plus 110. That's 160 divided by 4. So that will be 40. And then you will take this set and do 90 plus 150. That's 240 divided by 4, which is 60. And then the next set is 110 plus 170, 280 divided by 4 is 70. So this process of data set reduction is called average pooling, which is use this moving window, right? So doing one window at a time and figure out the average of that window. And again, we went from 9 pixels to 4 pixels. We have reduced the data size by more than half, right? So again, a lot of convolutional neural network is really about how to flatten your data set, how to reduce it in a way that you still preserve some truths, but you don't need to process as much data. So once you reduce the data set, it's a little bit more manageable and you can run your model in a more reasonable time frame. So a lot of you also ask me why my models take such a long time to run. Well, hopefully you understand the massive amount of data from images, right? So you're just doing that. I mean, TensorFlow is doing a lot of the really heavy lifting behind the scene for you, transforming all the images into numbers the computers can understand. It is just processing a massive amount of zeros and ones, from all the different images you're getting. So of course it's going to be slow. A couple of things that you can do because you're comparing models in terms of their other features, you can, we're not asking you to see the effect of epochs. So you don't have to run a lot of epochs. As long as you're comparing apples to apples, you're comparing all these different models using the same number of epochs, you're still running a pretty fair experiment. So make sure that you use the same number of epochs, for different models that you're trying. That's just a good practice for running for experimental design. But you can reduce your number of epochs down to maybe as low as 5, just so that you can finish your models in a more reasonable time frame. You should also use GPU, which will run things a lot faster, right? So that you can get better computer resources if you do that on Colab. Now, if you have GPU on your own computer, that's perfect. But if you don't have GPU, you can use free GPU on Colab. So that should also speed up your modeling time. With that, good luck with Module 5, and I look forward to working with you on the natural language processing model.